Okay, how you guys doing? My name is Daniel Phelps. I'm here at York College's Makerspace, affectionately called The Bridge. I wanted to talk to you guys about a few things today. Just got a new, brand new Kickstarter campaign 3D printer from Blue Eagle Labs. It's called the Kossel Clear. Now, if you're familiar with 3D printing, you'll realize that, or you'll know that a Kossel printer is a Delta 3D printer. It uses a gantry system to print in a very different fashion. We were very lucky that we were able to pick this up, and that Blue Eagle Labs was able to put together a package for the Makerspace that included a couple extras, such as the LCD screen, the knob, some really nice extrusion, and I actually got this in black acrylic. That's one of the great things about the Kossel Clear. It's made with acrylic, very inexpensive, cheap parts. Not cheap, but just inexpensive parts. Now, this was a Kickstarter campaign that finished up, I think, 2 or 3 months ago. All the backers have gotten their items, and now they're selling this online. So just go to blueeaglelabs.com if you want to take a look at what they have. This was, I think, the MSRP on this for, I got the PLA version. It was $760, where the ABS version is about $790. That may be different, but you can take a look on their website. So I want to do an unboxing video. I actually got this last night, and it was raining, and I opened it up, and I was really excited to get into it. So, you know, for all you unboxing traditionalists, it's already been opened, but all I did when I opened it was take a look to see if everything was in the box that I ordered, which was great. So what we have here is we have this looks like a bill of materials for the 3D printer that I ordered. We have an acrylic bed. This is for the PLA, so this is acrylic, and it's 200 millimeters by 200 millimeters, so it's a nice big circle. Now, this Blue Eagle Labs printer, the Kossel Clear, can do 200 by 200 by 250, so it can do a fairly tall object. And you know, because we're using Slicer and a bunch of open source software where you can just type in what size bed you have, we can add new aluminum extrusion arms and make this as tall as we really want. But this is a good foundation for what we're doing. We have, looks like, nicely wrapped in saran wrap, colored saran wrap from Christmas. These are the stepper motors. We've got 4 of them in here, so 3 for the gantry system and 1 for the extruder. And it looks like they just kind of took a bulk package and cut this in half. It's really cool. I like it. What do we have here? We have LCD monitor and power supply with the cord. So this is the LCD monitor. Essentially, this is a $60 add-on that allows you to print with an SD card. You just upload the G code to an SD card, pop it on here, and you can print standalone, which is really nice. Here at our Makerspace, we do have a couple MakerBots and some higher end printers on the way. And I really do like the SD card printing, mainly because if my computer crashes, or you know, I'm laptop based, so if I want to take my laptop anywhere, it continues to print, which is really good. I highly suggest this upgrade, and so do many of the Thorns. What else do we have here? We have a nice little box. It has my name on it. Open beam, PLA. This is why I like going to small companies to source these materials. Now, this is a kit, so it doesn't come with a lot of instructions. They do have a 34, maybe even less, part video series on YouTube that shows you how to put this all together, which is very nice. And it's very concise. So it looks like we have, this is I think they call this the Bowler tube, some 3D printed parts. This is the auto calibration. This is the auto calibration piece. One of the things that's very attractive that I found with this is that it has actually an auto calibration attachment that allows the printer itself to level itself, self-leveling, which is very nice. Apparently it doesn't work too well, but we'll see if we can get it running a little bit better. We have some of our end stops here, end stops with all of our wiring. We have our tube. This is for our filament. And then we have the hot end. This is the extruder. I opted for a 0.04 millimeter extruder just because that's what I'm used to with the MakerBots that we have here and the other FDM or FFF printers that we have. It's fairly standard. Uses a Mark 7 extruder, which is really nice. What else do we got here? Various bearings and bushings, which is nice. And this is really cool. I like this. You can tell it's from a company that's sourcing these materials from online. But this is Trax. It's fastest name in radio control, and I only know that because of a lot of the drone stuff that we do here at the college. So these are just hex nuts and stuff like that, which is really kind of neat. Here we have, this is our Arduino 2560 Mega. It looks like a Mega clone. Does not look like a standard Arduino. Yep, it's definitely a clone. It doesn't include any of the Arduino silk screening on it, which is fine. You can replace it if you wish. And then what we have, this is our stepper motor board. Okay, so I think they call this a ramps board, but this actually controls all of our stepper motors and is an add-on board for our Arduino. So they'll mate just like this, and the Arduino will control the stepper boards through here. All of our main power will go through this board as well, and power our stepper motors and our heat bed if we choose to add one later. Here are our really cool laser cut acrylic parts. I opted for the Kossel clear, but it's black. Traditionally, or for the Kickstarter backers, I believe that the Kossel clear, the reason why they called it the Kossel clear was that it uses clear acrylic, and it kind of gives that mid-90s where everything's clear and you can see inside and see how it works, which is really cool. Unfortunately, they were out of that. I would have definitely opted for that because one of the reasons why I wanted a large Delta 3D printer like this is because I can have students walk around the printer itself and see it print from 360 degrees. Things like the MakerBot, any of our Stratasys systems that we're going to have here pretty soon, you can only see through a small window, and the students really don't like that as much. And we can't really hook, line, and sinker them with our program if they can't see how some of this stuff works. It looks like we have some belts, okay, and some cogs for our stepper motors. Here is an LCD, one of the LCD screens here, a bunch of various parts, little knobs, nice big buttons, on and off buttons. Love this stuff, and it looks like they've upgraded a lot of the hardware. So when they originally did the design, I think they've been starting to add to it. These crimper pieces are for the main switch, and before they wanted you to, or they as in Blue Eagle Labs, wanted you to do a lot of soldering, and I think they've kind of overcome some of those things here. We have a USB cable, USB B to A, sourced from Monoprice, which is nice. And then here are the major components. Now, this is all laser cut acrylic, okay? It's not machined aluminum, it's not steel, it's not anything like that. The laser cut acrylic parts are literally bolted together with M3 nuts with machine thread on it. So when you're bolting them together, you want to make sure that you don't over tighten them or anything like that, because a lot of these pieces don't tighten together with nuts. They actually just tighten together with the friction from the acrylic, which makes it fairly inexpensive. And since these are laser cut, you can have them relasered if you wanted to make replacement parts or create another one. And that also goes to show this is based off of their open source design. They've posted all the STL files for the acrylic and all the STL files for any of the 3D printed parts on their website. So just go to blueeaglelabs.com. And then what we have here are a bag o' nuts and bolts. These are mostly all M3 from what I can tell from watching the videos. And yes, I've watched all of the how-to videos on this thing already just to kind of see if there's anything that I need to look out for. But there's a lot of nuts. I want to be very careful with these that I don't lose them. It's good to know that I do believe a lot of Home Depots are rolling out new fastener sections that actually have M3, M2, and M1 nuts and bolts, which they haven't had in the past. You would have to go to an RC hobby store and source out something like this, a Trax, which, for the 10 nuts and bolts that you get in here, it's probably $3 or $4, which actually seems like a steal when you think about how much Home Depot is. But either way, it's getting a lot easier to find hex nuts and bolts. Also, Home Depot at all the major locations and if you haven't heard yet, and I'm probably dating this video by saying this, all the Home Depots in the major metropolitan areas of New York, San Francisco, LA, I think Chicago, at select stores they actually have MakerBot kiosks where you can buy filament, you can buy MakerBot 5th generations, and a few other things. I think maybe replacement printheads. Which is really cool. So once you build a printer like this, you can actually go and find PLA readily available and possibly find parts to either build or fix this when it does break. And as much as I want to assume that this is never going to break, it's probably going to break every week if it's like any of the other printers that I've had experience with. So so what we have here. The basis of the frame for this is not just acrylic. The acrylic are the fasteners for the main structure. And the main structure of the Kossel Clear is extruded aluminum. And I really love extruded aluminum. I think it's one of the best things. It's Tinker Toys for adults. It's actually very easy to mass produce, very easy to source. And I'm just going to take away some of the saran wrap here. And I actually had to upgrade to, I had to because they didn't have anything else in stock. I upgraded to the black anodized extruded aluminum. So we have black acrylic, black anodization on our extruded aluminum, and I think it's going to give it a really cool look. Any of the other, I'm a black and red type of person, so I think any of the other 3D printed parts, I'm probably going to print out in red, and if I create any parts specifically for external fan units that I'm going to add to this, where it cools the hot end and it also cools the PLA as it's being laid down to the platform, I'll probably do in red and kind of create a motif like that. Or, you know, maybe I'll do yellow. We'll do a bumblebee thing. Okay, so, that looks like it. So, you know, so one of the things that I wanted to talk about today, that's not just how cool a 3D printer is, you know, one of the reasons why we're doing a 3D printer like this. We have multiple 3D printers here in our makerspace, but what we don't have is one that's been hand built, hand taken down, and also one that's very different than any that you can buy in the store. One of the benefits to a Delta 3D printer is one that just looks cool, but you can also go unlimited to a certain extent on your Z height. So with this, I really do believe that we can create a customizable printer using these parts, and because it's open source, and because it's a great Kickstarter project, and because it's based off of the Sailfish firmware, we can use it with a lot of different other open source printing packages. So you know, one of the big ideas that we push in not only our building and hacking course, but in all of our other courses, is trying to use open software, open firmware, make it your own, and at the same time, really kind of understand how, if you can understand how things work, and specifically how FDM or FFF 3D printers work, you can understand how to fix them very quickly. So as the market starts to go away from home-built DIY solution, 3D printing solutions, and more towards, you know, pre-packaged, unfixable, you know, as where MakerBot's going right now, I think that there's going to be another resurgence in solutions like this that use great firmware, great software that's all open source, and that people can just buy in a kit form and easily put together over 2 or 3 hours. So that's the Blue Eagle Labs Kossel Clear. There's lots of other Kossel printers out there that are based off the Delta design, but this Kossel Clear came out a few months ago, and I hope that it's great. So I also hope to have a few videos as I go through the build process and let you guys know where I am with this and some of the problems I'm running into. Oh, and another thing. You know, one of the great things about this is it came out a few months ago, and there's a great wiki on the RepRap wiki, which is, if you're not familiar with the RepRap project, it's what kind of started this revolution, including MakerBot and all these other spin-off 3D printers. But if you go to the Kossel Clear RepRap wiki, you can read all about it, and kind of you can see what people are starting to hack at it. And you know, I hope to add a lot to the community with this product, specifically for additional 3D printed parts, because it is a new design or a new kind of a new component design for a very traditional Delta style printer. So definitely try the RepRap wiki for the Kossel Clear. There's also Kossel Minis and all these other things. So stay tuned. Thanks for watching if you've gotten this far, and see you later.